Jack Allen. I will be your moderator for today. Joining us is our presenter, Chip Childers. Chip Childers is the Vice President of Product Strategy of CumuLogic. Chip's previous role was as Chief Architect of SunGard's cloud service offerings. He also served as the first Vice President of Apache Cloud Stack for the Apache Software Foundation. Throughout our presentation, we encourage you to submit questions using the questions pane on GoToWebinar. We will answer questions live at the end of the presentation. Please keep in mind that all participants are in listen-only mode. We are recording today's session, and we'll email a link to the recording tomorrow and post the links on the CumuLogic website. Let's get started. Chip, I'm turning it over to you, sir.
Thanks, Jack, and thank you everybody for joining. Appreciate it. We appreciate your time. Couple things. We're going to walk through a little bit of a presentation that's going to give you some context around CumuLogic itself and our product. Talk about how we've integrated with Cloud Foundry, and then we'll switch over to demo mode, and I'll walk through the integration and show how it actually functions with a live application. At the end of that, we'll then take some questions. Please do note down anything that you want to ask, or just send it in via the question tool for the webinar, so that Jack will be able to let me know what questions you've had over the course of the discussion. So the first thing we want to do is to define what CumuLogic means when we talk about on-premise database as a service. Now, what this is the self-service delivery of database engines that can be done within the enterprise environment. So whether this is on top of a private cloud, whether it's utilizing bare metal resources, it's a very simple way for application owners, be they developers or administrators, to request via web form or API a database. So what CumuLogic has done is that we've spent the time to provide an integration with Cloud Foundry. Now, Cloud Foundry is one of the leading PaaS platforms that are out there, integrated application PaaS environments. And CumuLogic offers database as a service functions that are production grade, backed up, monitored, and all of this can occur within the firewall. And we believe that by combining these two technologies, enterprise IT is really opening up to a number of different architectural options. It isn't required that every database lives within the Cloud Foundry environment, and every application might not be within Cloud Foundry. But these databases that we can tie into Cloud Foundry apps are fully managed, they are backed up, they're monitored, and they're production grade. So again, why a broker? Just drilling in a little bit. We really believe that applications deserve the highest quality and robust databases that they can get. We also believe that there's a need for choice for application owners to be able to decide that they want to use MongoDB or MySQL or Percona or even Couchbase. And when deploying these databases, oftentimes developers skip the steps of making sure that it's backed up. But the data is the most important thing to an application, especially persistent data. While the app code itself might be ephemeral, anything that you're persisting, you really want to make sure it's protected. And CumuLogic is the industry-leading multi-engine on-premise database as a service platform. We deliver that capability I just described that the app owners need in a very clean, self-service manner. And then, of course, Cloud Foundry being a great example of a PaaS that can be deployed really on any infrastructure, it ties in very nicely to the CumuLogic environment. I'll dig into two different specific modules that CumuLogic has here. Our database as a service functionality is roughly split into the relational database services and NoSQL database services. They're largely the same type of operations. However, since some of the operational traits of these different types of data stores are distinct enough, we've chosen to break them apart down those two classifications, relational and NoSQL. Our relational database service as a standalone offering is really it's an RDS equivalent capability. So Amazon's RDS is the Amazon Relational Database Service. It allows users to, and our software allows users to select the engine that they want to deploy. Currently, we support both MySQL as well as the Percona XtraDB engine. You also get to select things like the level of availability you're looking for. And so if you want a single node instance, that's one type of request. If you want a multi-node Percona cluster, perhaps even spanning multiple data centers, that's another possibility. In the third quarter of this year, we'll be adding support for both Oracle as well as Microsoft SQL Server to this offering. Our NoSQL database services function in a very similar way. The two engines that we're supporting here are both MongoDB and Couchbase. Thinking about what I described with the relational database, how you could request just a simple single node instance all the way up through potentially even multi-data center replicated topologies, the same thing applies for both Mongo and Couchbase. Mongo in particular, we're able to deliver everything from, again, single nodes, multi-node replica sets, even fully sharded infrastructures, which includes the deployment of query routers, config servers, monitoring agents, and then all of the members of each shard's individual replica set. So using our services, you can really scale from that developer use case test and staging infrastructure, and then all the way up to very large production deployments of these systems. The way that we actually deploy any databases are through the use of some underlying virtualization environment, or we can work with pre-provisioned pools of just really bare-bones CentOS installations running on bare metal or in VMs. Different deployment options give a lot of flexibility depending on what you have available inside of your local data center, but you still get the same result, which is easy to deploy database services. When you're dealing with a virtual environment and we're able to dynamically determine the size of each discrete node, that gives you a lot of power, right? And it lets each one of the deployed database services really be tuned for the appropriate use case. If for a particular workload, you might not need more than 3 nodes in a cluster, but you want those nodes to be very, very large, that's easily accomplished. You can also go with more of a horizontal scale-out approach depending on the technology. And for example, you could do a number of very, very small nodes that are part of a replica set or part of a cluster. And again, this is all data center aware, and so we're able to target multiple clouds or multiple zones within a cloud as part of these deployed topologies very easily. Just a couple of clicks to add things like multi-zone support. Now, once the database has been deployed, we're going to be monitoring it. Our software monitors it for you. And we monitor for both performance and capacity metrics. Those get reported back. Your DBAs can review it. Your IT admin teams can review those metrics. You can give your application owners access to those metrics as well. But much more importantly, the CumuLogic controller is going to maintain health checks for everything that it deploys. And in any deployment topology that includes some high availability attributes, be it a cluster or a multi-zone replica or just even a multi-node replicated environment, if we notice that there's an outage within that topology, we'll make sure that the node that's having a problem goes offline. Perhaps the VM is fully destroyed as part of that recovery process. We'll bring a new node back into the cluster, rejoin it, or reestablish replication jobs. All of that happens automatically on behalf of your users. We do provide a number of different options to both the administrators as well as the users that are using the CumuLogic tool directly that let you pierce the veil of the self-service abstraction a bit and to tune some of the detailed configuration values that you might normally tune if you were manually installing the software. So this could be things like various cache sizes, buffer sizes, max connection counts. And by doing that, you can actually create these parameter groups and then tie them to simple subscriptions that make it one click plus a name for an end user to request that well-tuned database configuration. I also mentioned that we handle data backups. This is critical for production data. And so the CumuLogic controller by default is going to perform automated nightly backups with a user-definable retention policy for a number of days. The user can choose to specify a specific window within which the backups will run, or they could just simply allow our controller to determine best time of day. We also provide them access to self-service restoration, and that works for two different use cases. The first is a disaster recovery situation where something happened to your data and you need to restore it so your application can be brought back online. The second use case, though, is because we can do restorations from previous backups, you can restore to a brand new instance and perhaps point your staging environment to a copy of your production data. So lots of flexibility in how all that works. And again, it's just a self-service interface, both a web UI as well as APIs. Our core platform, just a couple of points to make here on this architecture slide. Our core platform works on a large number of infrastructure options. We work with vCloud, Cloud Platform, CloudStack, several OpenStack distributions, as well as Eucalyptus. These tend to be the software environments that we come into within enterprise accounts. Again, we can also work with both bare metal, or we can work with pools of just basic virtual machines. All that's required for either one of those pre-provisioned systems are that they have a CentOS operating system pre-installed, they're on the network, and our controllers made aware of them as part of a pre-provisioned pool, and it will then treat each one of those systems as a unit of allocatable capacity. So instead of creating a VM on demand, it would just allocate one of the ones that had been previously set up with the basic operating system. The other thing we can do is, because we support all the APIs of the software that I mentioned earlier, we can work with a large number of public clouds as well. These are, of course, Amazon, Rackspace, HP. We support a large number of CloudStack-based clouds as well, other OpenStack-based clouds. And so for an enterprise, you really then are able to put yourself in a position where you've got a consistent experience regardless of the target infrastructure you're deploying your apps to. And one of our controllers can even be set up to talk to up to 20 of these target clouds concurrently and use them as the basic virtual infrastructure necessary to deliver the database services on top. The way our platform is built is that we've got a core framework that handles all of the common tasks, everything from the abstraction of the infrastructure tasks, automated operations and task scheduling, role-based access control and governance. And we've defined that core framework in a way that allows us to deliver what are really 4 key modules as plugins to the framework. So we offer that relational database service that I mentioned earlier with MySQL and Percona, with Oracle and Microsoft SQL Server coming soon. We also offer a NoSQL service with Mongo and Couchbase. And in addition, we have Elasticache style functionality. These are Mcache clusters, and we offer messaging as a service as well with RabbitMQ. For the enterprises, we also support IBM WebSphere MQ. All of this exposes a RESTful API northbound. There's a user interface that you'll see during the course of the demo. That's been built on top of our own APIs. And then we use those APIs that I'm referring to as actually the foundation for the service broker interface that we can then use to tie into a Cloud Foundry deployment. So how do the two work together? What you can see here in this diagram is that very, very roughly you would have a Cloud Foundry environment. That Cloud Foundry environment is made up of a number of different moving parts, right? There's the droplet execution environment, there's the basic controller app. But what Cloud Foundry wants is when it wants to tie into external services, there's an API specification called the Service Broker API. And that defines 5 primary functions. It defines a catalog request, which will expose a number of service definitions, and in CumuLogic terminology, those are subscriptions. It then has to support the creation of services and the deletion of services, and then the binding and unbinding of those services to apps. We'll walk through some of those steps of the application workflow so you can see them live from the Cloud Foundry perspective as we go, again, into the demo. Now, on the CumuLogic side, similar type of diagram for what you saw earlier, roughly condensed a bit. The Service Broker block is that interface that we've released as the technical preview. It is implementing the Cloud Foundry Service Broker API version 2 to support those 5 primary operations. And what it does is it actually translates those calls into the CumuLogic native API on your behalf and works with that CumuLogic controller to perform all of those operations. And so that includes pulling out the subscriptions that have been predefined within CumuLogic and presenting them as a catalog to the Cloud Foundry user. It also then includes all of the provisioning activity as well as the support for getting access credentials and host names for a deployed service, which is what's required for the binding operation. Again, we do support 4 key databases today, very commonly used: MySQL, Percona, Couchbase, and Mongo. And each of them, when defining a subscription, can be built, can be pre-designed to have varying levels of that high availability architecture. And I'll actually show you how, in my demo environment, I'm exposing 2 different subscription options for MongoDB. One of them is a single-node Mongo database, and the other is a multi-node replica set. By keeping the CumuLogic environment available, though, what you're actually also able to support is the use of the user console by your DBA team. And your IT ops team can control the whole CumuLogic platform and deal with things like defining additional subscriptions that you might want to expose to your app teams. The nice part about this is that really, whenever you implement database as a service, what you're hopefully doing is you're allowing your DBAs to get out of the process of manually provisioning databases, and you're letting them move into more of an advisory role where they can work closely with the application development teams on best practices for working with databases. And so the same DBAs can use the CumuLogic controller to help define things in those subscriptions, like what does it mean to be a read-optimized database environment? What does it mean to be a heavy write-optimized database environment? And they get to take those skills and really codify them into a self-service catalog that the app teams can take advantage of. So with that, what I'm going to do is I'm going to switch over and walk through a demo with you. And so there's a few things that I'm going to do. Some of this is going to be looking at a web browser. Other parts of it will be via the command line, so you can get a feel for how the Cloud Foundry user will experience the process and some of the operations of the bridge itself. So the screen that you're looking at right now is a view into the CumuLogic dashboard. And specifically, we're looking at the NoSQL service. And what we can see is that we have a NoSQL engine, a standalone MongoDB database that's been deployed. This database is actually was created through the Cloud Foundry interface, but it's been pre-deployed, so we can just walk through some of the basic features that CumuLogic has during the demo process. So what an administrator can do, or even the user if you choose to give them access to the CumuLogic views, they can take a look at things like the details about the database deployment. That includes sizing, what cloud it's running on. In this case, I have the Mongo database deployed to EC2. They can take a look at change events that are occurring during the provisioning process, during ongoing maintenance of the system. They get visibility into some performance metrics for that database environment. There's a number of different metrics that are exposed, and largely they'll depend on exactly what engine we're working with. But in this particular case, we're looking at a background flush, connection counts, potentially the journal metric as well. Next, you'll see some access credentials. Now, this is important because these access credentials are what are going to be programmatically shared with the application over on the Cloud Foundry side. We also have some capacity metrics available within the Databases tab. It gives you a list of all the databases within that Mongo environment. And then collections as well. That'll be a list of all of the collections that exist within each one of those databases. All right, last, the other thing we're able to do is we're able to provide the user with direct access to the Mongo logs, or in the case of MySQL, the MySQL logs, the slow query logs. These can be viewed live and retrieved live, or they can be downloaded for analysis offline. They can also be pulled out of the CumuLogic environment through the API. So you could bring them into some log analytics tool. The last thing I'll point out is that for MongoDB deployments specifically, we do actually support an integration with MMS for some of the functions that MMS provides. Some other options we have available for external support include AppDynamics and New Relic, and those could be set up within the CumuLogic platform so that any node for any service that's deployed is automatically registered within those application performance monitoring tools. Now, I mentioned that we deal with automated backups, and that happens each night, either based on the specified window or it happens on demand when a user comes in here and actually wants to perform a specific backup. So I would very easily say create snapshot. I would select the instance that I want to back up, and I would ask it to create that backup. Now, I had previously done a manual backup, and you can see it's just as easy to do a restoration. I can take that manual backup. I can ask to restore. I would describe a new instance name, target a particular cloud, potentially even resize and change things like the port. And that'll bring all the data from that initial backup back online into a new environment for you. The other thing I'm able to do, once the database itself has been deployed, even if it's a standalone MongoDB instance, you can come in here as an administrator or as the user that owns this deployed node, and you could add additional nodes. And so we could go from a single node up to, we normally jump from 1 to 3, but you can go even higher with Mongo. You can also do things like modify the backup schedule. I mentioned that parameter group as well. We can pick a new set of detailed configuration values and have those be applied. So this is the CumuLogic view of a deployed database service. What I'm going to do now is I'm going to switch over to the command line for a bit, and we're going to walk through a Cloud Foundry experience when interacting with CumuLogic. So what I have set up on my local laptop is I have a version of Cloud Foundry running using the BOSH Lite code that the Cloud Foundry community has made available. This basically means that I've got a virtual machine running on my local system. Within that virtual machine, it has all of the various components that make up the Cloud Foundry environment. And you can see I've got that running virtual machine. I can do a quick check to confirm that all of the Cloud Foundry components are happily running. Great, so we've got no problems. Everything seems to be ready to go. The other thing that we need to do is we actually need to have the Cloud Foundry, CumuLogic Cloud Foundry Service Broker code itself up and running, because this is a simple Sinatra-based web application written in Ruby. It serves as the gateway between Cloud Foundry and CumuLogic, does a number of basic translations between the two different API requirements, and it's able to allow us to bridge those two systems. So the first thing that needs to occur, and all this is documented in our installation instructions, but the first thing you need to do is actually set up a config file that's going to specify some things like the URL of the CumuLogic system, a username, a password, a number of IDs, whether SSL is enabled, and there's a debug flag if you need to debug things, it will turn on debug logging. So I've downloaded the code. I've got my config file ready to go. And it's very simple, actually. Once you download the code, you would do a bundle install and then a rack up. Rack is the web serving framework that will start off the process. So the broker is now running. It is currently listening on port 9292. And then a way that I can verify that it's up and running is to just do a simple curl request here. So I'll log in. There's a basic auth requirement right now that Cloud Foundry needs to be in place for any service broker because it wants to authenticate itself. And I've set this locally just to admin. I'm going to request from my local IP address the catalog out of the system. And what you can see that got returned here is we've got a list of services, and specifically the CumuLogic NoSQL service with 2 different subscriptions, or in Cloud Foundry terms, plans, have been exposed. We've got a basic Mongo standalone virtual machine. We also have a basic MongoDB 3-node replica set. And this could also include things like a sharded environment, so that it could be very, very large as well. So that's what I've exposed today out of the CumuLogic controller. And we now have the service broker interface running, which means we should take a look at what it looks like from a Cloud Foundry user's perspective. So I'm now looking at a simple Hello World application. This is written in Ruby. All it is going to do is really provide 2 different URL routes. One of them is going to be the root of the application, which is going to pull the access details out of the VCAP services environment variable, the host, the port, usernames, and passwords. It's then going to insert a value or a document into the collection, and then it's just going to return all of the currently stored documents from that collection. Very simple, wasn't intended to demonstrate how Mongo works as much to show that the connection can be established and used. The other route that I've got available is just /env, which is going to dump the VCAP services environment variable out to the screen. That's useful because it's good for debugging. You would never do this in kind of a real-world application. So that's it. That's all this application really does. So what I'm going to do is I'm going to do a CF push on this app. And it's going to go through the normal Cloud Foundry process of taking the Ruby app itself, bundling it up, staging it, and then getting it into an executable environment, and then set up the URL route necessary for me to reach it. All right, so it's saying that it's available at helloworld.10.244.0.34.zip.io. Obviously, it's a test environment. And so I've got this here. And we'll just take a look to see what's in the VCAP services environment variable. Now, I haven't bound anything to the application. No backend service is bound, and so there's really nothing that's available today, so you can see it's an empty collection. So the next thing we're going to do is we're going to go through the process of creating a new MongoDB service. The CF create service command is how you do this. And then what you find here is that service number 1, the CL NoSQL service, that's the service that is being exposed by our broker. So that's the CumuLogic NoSQL service. I can just go ahead and pick the default name as well. And then I get a selection of the plans. In this case, I'm going to pick the Mongo Service standalone VM. Now that's going to go through the process of creating the service. What I'm going to do now is I'm going to switch over to back to our CumuLogic view. And one of the things you'll note here is that that create service call from Cloud Foundry has actually returned with success. Now, because CumuLogic will go through the process of creating that backend service, including the requests necessary to establish the virtual infrastructure, it's going to take a little bit longer than the typical Cloud Foundry service that might be fully pre-provisioned ahead of time might take. And so this is one of the areas where, as the Cloud Foundry community evolves the Cloud Foundry product, we are in particular looking forward to a time when the Service Broker API supports asynchronous task execution for provisioning. Because right now we're waiting on Amazon to spin up some virtual machines for this newly requested Mongo environment. You can see that we're going through the process. We'll come back to this later, but instead of waiting for EC2 to catch up to us, we're just going to go ahead and move forward. Now you can see that if I run the CF services command, I already have, I had a pre-existing service that I created right before our demo. It's called CL NoSQL demo. The one that I just requested is listed here as available, Neither one of them have any applications bound to them. But I'm going to use this one that I pre-provisioned that we use to also show things like backup services and monitoring data. The next command we'll use as an application developer is to do a CF bind service. And my application is hello world. I'm going to bind it to the CL NoSQL demo service. Now that's been bound. And when I look at the CF services list, I'll see that hello world is in the bound apps column for that service. And in order to pick up the new vCap services values, I'm going to do a CF restart on my hello world application. Great, now it's back. I'll go back. Let's take a look at what's in the environment variable. And ta-da, there we are. We've got the URI necessary, the username, password, host, address, port, as well as the database details that we're going to need within our application to actually access the deployed Mongo environment. So I'm going to go ahead and remove the env URL, and let's actually watch the app communicate with the back end. So each time I refresh this, what we're doing is we're adding the exact same document to the collection. And keep in mind that all we're doing is we're dumping all of the documents in this collection out to the response body. So we're growing the data, and that's all working well. So that's it. We've got it up and running. You've got a Mongo backend. That Mongo backend, you know, is backed up. You know that you've got monitoring telemetry into it. You know that if you had selected a high availability topology for Mongo, that the CumuLogic controller will ensure that the health of the environment and manage it over the course of its life cycle. And you also know that your administrators and DBAs have the ability to go in and scale that environment to add additional nodes and perform a large number of additional self-service functions against it. So we'll go ahead and back out here as well. We'll unbind the service from our Hello World application. And again, go through the process of restarting the app so that it picks up the environment change. And at this point, we don't have access to a database, so of course we're throwing errors. And you see that the environment is now empty. So that's it for the demo. What we'll do now, I guess, is switch over to taking any questions that might have come up. So, Jack, I guess back to you.
Thank you, Chip. Participants, I want to thank you for the questions that you've been submitting through the questions pane. We have a number of them, and we will get to those now, but I do encourage those that have questions, please submit in the questions pane, and we will get them asked. First, given that you are advertising that this is a technical preview, what are the limitations of the product today?
Yeah, so I mentioned one of them already, which is the fact that Cloud Foundry expects all service provisioning steps to be a synchronous operation. What we've done in some of our test environments is to increase the timeout that the cloud controller, the Cloud Foundry cloud controller will accept in order before it waits until or before it times out a particular provisioning request, and then used pre-provisioned back-end systems, bare metal or virtual machines, as the target for the CumuLogic controller to push Mongo or MySQL. That seems to work fairly well. So what we're hoping is that once Cloud Foundry is implemented an asynchronous callback pattern for service provisioning, everything will work much more smoothly, and the application owner will be able to get some feedback via the Cloud Foundry tooling about how the CumuLogic provisioning process is progressing and when it's complete. So I would say that's the largest drawback at this point. There's also some additional work to do around passing the full metadata from our catalog of subscriptions back into the Cloud Foundry environment, so that UIs like the Pivotal CF framework can get full access to details around pricing or details like descriptions that make that UI useful for the users within those environments.
Thank you very much, Chip. We have a question. You support Terremark? Question mark. And my interpretation of that is that's Terremark, the service provider. I worked with those guys closely in a previous life, Randy Rowland, Jason Lockhead, Marvin Wheeler. They've since been acquired by Verizon. So my belief is this is related to Terremark, Verizon, the service provider.
Yeah, that's a great question. So offhand, I'm not familiar with exactly what APIs they're exposing for their various services, and I do know that they have a large number of different services out there. If we're talking about the newly released Verizon/Terremark public cloud, we would have to take a look at that. Our goal from the CumuLogic perspective is to support the most pervasive APIs that are out there. Again, you saw support for a large number of them. It is relatively easy for us to add additional IaaS support when necessary. So, if you've got a use case where that would be interesting to your company, just let us know. Let's talk about the opportunity together, and perhaps we can figure out how to either validate that it supports an API that we can communicate with already, or whether we have to extend the core CumuLogic product to support a new target infrastructure.
Yeah, and I would just add at that time, and it may have changed, Terremark was at that time when I worked with them using VMware, vCloud, and vCloud vDirector. And so if that's still the case, probably we can easily integrate with them, may already be integrated with them, but that was several years ago, and their infrastructure as a service, cloud platform layer may have changed since then. So that's all we can add to that topic for the time being. Another question, and again, thank you so much, participants. Great questions you're asking. Keep them coming through the questions pane. Does this integration work with Pivotal's distribution of Cloud Foundry?
Yep, good question. So we did talk about the fact that there's some additional metadata that would need to be added. Now, the Pivotal CF distribution, or Pivotal CF product, is Cloud Foundry at its core. The registration of external service brokers is supported, and everything that I did within my local environment should be possible with Pivotal CF. Where we'll need to spend a little bit of additional time working on the broker is again in some of that metadata that will make it prettier when exposed or when viewed from the CF web UI.
Thank you so much, Chip. Next question. How is the licensing of the underneath services handled? By customer, by CumuLogic, on demand? Those are question marks, following question marks.
Yeah, that's a great question. So if you notice the 4 technologies that we currently have available within the CumuLogic platform's DBaaS functionality are all open source options. Now, so that's MySQL, that's Percona, ExtraDB, that is Mongo, and that is Couchbase. Now, depending on what your needs are, you may choose to license one of those technologies at an enterprise level from the appropriate company. Now, CumuLogic doesn't deal with the licensing for that. We really operate as a control plane, and we can provision on your behalf, and we can manage on your behalf. But you would work out those licensing terms with the appropriate party. Now, that said, though, you can use this because we've defaulted to the open source options, which means you can use this today as is, just with the CumuLogic controller.
Thank you so much, Chip. Another question. Participants, thank you for the questions coming in. Does the CumuLogic platform need to run on the same infrastructure as the Cloud Foundry environment?
It does not, and in fact, what you saw in the demo today was I had Cloud Foundry running on my local laptop, and CumuLogic was not only was its controller running in EC2, but it was targeting the EC2 infrastructure environment for the services it was provisioning. And so each one of those components can live in completely distinct infrastructure environments. They can be geographically distributed. A lot of flexibility there. Now that said, one of the things that we think is very compelling for Cloud Foundry users or enterprises that are deploying Cloud Foundry or Pivotal CF is that if you have Cloud Foundry running within a particular infrastructure environment, it is extremely useful to have high-quality database as a service running in that same environment, or at least very close to it. Lots of reasons for that. But predominantly, I think that latency is a significant one, right? That's why on-premise database as a service is a very powerful feature for you. Second, if you're dealing with any type of sensitive data, you might have a reason to keep it within your infrastructure. That's not necessarily the case, but that's certainly a possibility that might warrant ensuring that it's local. But really, in the end, I think it comes down to it is extremely appropriate for applications to be deployed as close as they can be to the persistent data that they're going to be working with, especially if they're going to actively and frequently query and update those data stores.
Thank you, Chip. Another question has come through. Can CumuLogic handle upgrades, fixes, hot fixes, and so forth of shared and non-shared initiated databases?
Yeah, that's a great question. We do not support minor version upgrades today. That is a feature that's going to be coming in our Q3 release. It will operate similar to what you would expect out of the RDS environment from Amazon, where you as the operator of the CumuLogic platform will effectively add a new minor version upgrade option to a particular engine. Notice I said minor version because you wouldn't want to jump major versions automatically. But for the smaller releases, you would bring that new version in. You will set it as the active version, so all new services will be provisioned using that latest version. And then you will have controls that will allow you to pick a particular week within which the system will automatically go through the upgrade process for each one of the back-revved databases that have been deployed. So we've got that working in in development systems right now, and we're targeting our Q3 release for that type of function.
Wonderful, wonderful. Chip, we have another 4 or 5 questions that have come through. Here's the first one. What kind of SLA can be reached with the high available failover to each database, i.e., do you have some reference numbers there of existing customers or your test environment?
Yeah, that is a great question. We don't have any reference numbers that we can point to. And I think that, that's something that would be very valuable for us to do because obviously the question is being asked. I will say, however, that the ability to recover from a failure is going to be multifaceted, and the speed at which that occurs is also going to be multifaceted. So let's take a couple of examples. The first example would be something like a Percona XtraDB engine multi-node cluster. Now, in the event of an individual node outage, Percona itself has been built to work around that problem. And so the engine is going to resolve the individual node failure for the app, and the app shouldn't notice the outage. What the CumuLogic controller will do is deal with the steps that are typically taken by somebody manually today to restore service back to its full cluster size. So within about a 5-minute window, the CumuLogic controller is going to identify that node's gone offline. It's going to kill the VM if it still exists, and it's going to recreate a new one and then rejoin it to the cluster. Similarly, if you're talking about a multi-zone deployment, let's take, again, we'll use Percona as that example again. We're using the Percona replication technology to do master-master in both availability zones, but we're doing a DNS-based failover. So in that scenario, the application's communicating with the DNS hostname, and its database connections are going to Zone 1. When our controller identifies that Zone 1's gone offline, or that node within Zone 1 has gone offline, DNS is told to change the IP address that hostname is resolving to point to the secondary replica in another site. The controller will also make sure that replication has been halted in case this is potentially a up and down type of situation. So we'll kill the replication job, and then once we note that the service is stabilized and connectivity is stabilized on Zone 1 again, we'll recreate a node, and then we'll reestablish replication so that you return to having geographic redundancy. I hope that answered the question. I realize you were asking for some quantitative metrics, which we don't quite have, but you can see there's a lot of variability depending on which options the user's selecting, which engine they're selecting, and how your architecture, all the way up the stack, right, from infrastructure and fault domain isolation all the way up to choices you're making around how you're delivering the DNS failover.
Thank you, Chip. Next question. Are you also looking into commercial partnerships like Oracle, Microsoft SQL Server, and/or Sybase? I take that to be more, will our database as a service solutions support those engines, is how I interpret that question.
Yep, great question. So out of those three, the first two are on our Q3 release. That's both Oracle as well as Microsoft SQL Server. So we'll support them in a very similar way to what we're doing with MySQL and Percona. Those are both commercial products. It will require you as either the enterprise IT department, or if you're a service provider, it will require you to work out a licensing agreement with those individual companies before enabling the functionality within CumuLogic. Again, we operate as a control plane. We don't have any plans around Sybase. That's actually the first time we've been asked for that. But we've built the framework in a way that lets us onboard new databases relatively easily. We're also working on publishing a formal SDK, which will let customers and partners extend our core framework by adding additional database services, based on their individual needs or individual demand.
Perfect. Thank you so much, Chip. Do you have CumuLogic to implement in a private cloud as well? Great, fantastic question.
Yeah, so CumuLogic is software, and we are absolutely designed to be part of any cloud environment. So the way to think of this is that if you're an enterprise that has a private cloud, it's likely that you're running some type of infrastructure as a service software. CumuLogic can sit right next to that. Our software can be installed in your data center, sitting right next to your IaaS orchestration software, and can work with that software for the virtual infrastructure. But it could be part of a bigger portfolio of services that you give to your end users. So absolutely, we work in private cloud environments, and we work in against public clouds as well, and we work quite well for service providers.
Wonderful, thank you, Chip. And we'll put out an info line at our email address at the end so that you can contact us to discuss that in more detail if you like. Last question, is MariaDB supported?
MariaDB is not supported today. That is one that we have actually had requests for, and it's something that we've been looking at implementing. In all likelihood, it's something that we'll probably be doing either Q4 of this year or perhaps falling into the early part of next year.
Thank you so much, Chip. I see no other questions at this time. Participants, we really thank you for being so engaged and all the questions that you asked. We want to thank everyone for joining us today. As a reminder, you will receive an email with a link of today's presentation that will also be posted on our website. Also, we'd love to have you connect with us and keep the conversation going beyond today's events and today's questions. So feel free to reach out to us anytime via the email address info@cumulogic.com. On behalf of our presenters and panelists, Everyone here at CumuLogic, we hope this was a productive webinar for you. We thank you for your time. Have a good day or evening no matter where you may be. Thank you very much. Goodbye.